Welcome to Module 3 of IT Project Management. In this module, we will look at how we maximize the chance of reaching our target project value by being smart in choosing the right product development process and project lifecycle. This module focuses on understanding how project value is really the highest point of project success. We will also see how firms benefit from a clear product development process and wrap it into a flexible but structured project lifecycle. We will then spend some more time on predictive and agile models and revisit the criteria for when to select which kind of model for your project. Remember the story of the beautiful network management and configuration system from Module 1? The one where the sponsor loved the new system and thought they were getting value, but the users hated the system, returned to their old terminals, and $700 million in value was lost? If you do, keep going with this video. If you don't, please return to the Module 1 video. As a reminder, this true story alone blows the idea that a project is successful if it manages only the specification, cost, and schedule out of the water. Instead, the program manager should have first followed the IDEO design thinking principles, asking not only if the solution was feasible and viable, which it was, but was it desirable? Clearly not. So if the specification isn't right or the business context changes during the project, as in our story, that product will miss the most important target. It will not be valuable to the stakeholders who paid for it or who have to use it. The best project managers take responsibility for delivering business value, which consists of these three principles, plus managing those three key constraints of scope, schedule, and time effectively. That program manager in my true story, by the way, yeah, that one was fired once this crucial problem was discovered. So if you as the project manager need to deliver success in both the qualitative and the quantitative aspects of project management, all while ensuring that your users get exactly what they want, there is no question that you and your company need a defined process for getting projects done. A defined process reduces confusion and the risk of missing crucial components, such as the system usability issue we've seen with the network management software example. But understanding the user can get challenging. Often, users have trouble describing what they want, or they cannot agree. If that's a small number of users, you can probably broker a consensus. If that is a larger market segment, for example, all the users of an operating system, you will need to reach out to your marketing department for customer survey data and from there construct what is called a voice of the customer to deliver the right upgrade at the right time. This voice of the customer is, generally speaking, a numeric representation of how your users would transform your product if they could. In other words, once you know with how much certainty your users understand their own needs, you are ready to pick a development approach. One of your process options for your development lifecycle is the predictive structure. It gets you from requirements to release and turnover to operations in one straight line. This works best when our projects are small enough and we know exactly what our users need from us, so we have clear requirements and know exactly what we're going to build and how. This means we can easily predict a successful project outcome. It also means that if we are wrong at the beginning when we define the requirements, we will be doing a lot of work before we discover our mistakes. That's why failure in a waterfall model gets more expensive the closer we get to release. This makes the waterfall method high risk. Not all projects are cut out for the high-risk waterfall approach. When the uncertainty and frankly the budgets get bigger, so does the likelihood of failing. To reduce the cost impact of failure, we break the requirements up into smaller chunks and build, test, and release each of these chunks as a minimum viable product. We repeat this design, build, test, and release cycle until either all requirements are built or we run out of time and money. One of these iterations is commonly called a sprint. Now let's talk about Agile in a little more detail. Here's the cycle of one sprint. Keep in mind that based on the product owner's direction, sprints in your project can be 2 weeks up to 4 weeks long. The fun thing here is that we are starting with project initiation and requirements definition and high-level requirements, which really isn't all that different from waterfall. But then we start with our development and integrate and test as we work off the parts of the requirements in the backlog that we have committed to for this sprint. And as we prepare for this development with the user stories that come in our sprint backlog, we develop the test plan. In fact, we develop the test plan first before we even start developing the code. That way, we have a much better idea as to how we need to write the code, here called development 1 through development n, to pass the tests. So then, our first increment is done after 2 weeks, followed by the sprint review, in which we demonstrate what we have built, and the sprint retrospective, in which we discuss how well and how fast we have built our product and what went well and what didn't. But let's go back to the sprint review, that big demo meeting in which our system has to work. You will be in the room with not just the team, but also the product owner, other stakeholders from the client office, some of their users, and possibly even your boss. And at the end of this sprint review meeting stands the big question. Will the product owner accept the output of your work and you can release your product? Or will she send you back into your lab for rework and bug fixes? Any of this rework, which you're seeing on the bottom blue part of the arrow here, will have to become part of the next sprint. Obviously, if you have any rework and fixes to take care of, that limits the amount of new user stories that you can take on for the next sprint, even if the product owner insists that the normal number of stories will have to be built. Just like in a waterfall situation, the relationship between scope and time is real. And if you have enough budget, you might be able to add more people to the team to get the next sprint done without any problems. Or you might have to add 1 or 2 more sprints on to what you thought was the end of the project. But then it's also important to ensure that you keep track of the money. And when the money is used up and there are still user stories left in the backlog, that's not a good thing either. So, as you may have already guessed from this, Agile is not a free-for-all, and it certainly does not require less documentation and tracking. If anything, it requires intense attention to detail of both the product owner, who makes all the major decisions, and the Scrum Master, who ensures that the technical team has everything they need in order to be successful, and who gets to do all the tracking and reporting for the sprint reviews. As you have just learned, the entire Agile process starts with scope identification. Here, that means imagining how the end user would use your product. Quite often, this is where end users get to weigh in significantly through feature surveys, workflow observations, basically anything that helps the product owner envision what the product should be like so that it generates the biggest measurable organizational value. All the ways in which the system is being used are then captured in user stories. Writing user stories is hard. They have to be short, typically no longer than 1 sentence, so they can fit on a sticky note or a flashcard. They have to be written in the language of the end user, not the engineer or developer, to ensure that the words used show exactly what the user wants and how and why they want it. Once they are done, these user stories are collected and indexed in the product backlog. Each one represents, so to say, a part of a conceptual model. The technical team then takes the user stories that is the conceptual model, and uses them as the basis for greater elaboration into a technically more detailed design that can be built by an engineer or developer. To make the handoff between the product owner and the technical team easier, user stories have a specific format. It typically goes like this: as a, and then insert the end user's role or job title, I want, and then describe the action that they want to take, and then so that, to give the reason why they need to take this action. This very specific grammar allows technical personnel to easily write test plans for a particular role and focus on the feature that needs to be tested, and on the larger technical integration or workflow context. Here are a few examples. See how they follow this format? In the first example, the role is the user, so that story goes into the test plan for the user role. In the second story, the role is the administrator, so that test plan goes into the administrator role. In the user role test plan, we then write exact test steps for photo uploads. We also connect this story with another story that seems hidden in it, namely a photo sharing feature. That photo sharing feature will need its own story, of course, and will need to be connected to the upload screen in some way. The administrator story also contains a hidden story that may need even further elaboration. In other words, we need to ask questions about the word appropriate. Does the user want just an appropriate-inappropriate switch? Or age range levels, for example, appropriate for adults, inappropriate for children, appropriate for upper level management, not appropriate for individual contributors, that kind of thing? Or perhaps appropriate only for certain roles that exist in the organization's directory server? In other words, the last "so that" phrase can really be nothing or mushroom into a really big work effort. These questions of scope need to be clarified between the team and the product owner and the business level, at the latest in the sprint planning meeting. As you may have noticed, test planning here functions as an important step to, if not as a replacement for, product detail design. As developers write the test steps, they need to understand each keystroke and mouse click that the end user wants to make or not to make as they execute the user story. This is where a lot of technical detail planning for each test case and test step comes in. This detail planning helps developers write the code or engineers build the networks or hardware that is needed without having to ask too many questions. So precision and a great working relationship with the product owner, who will most likely be sitting in the same office with the developers or engineers, is absolutely critical. Remember that Agile development is all about developing small increments really fast in a really collaborative manner with quick question and answer turnarounds to minimize any waste of time. Here is an example of a user story from a hotel reservation website with the test steps that show how many features are hiding under the sentence in the blue box. Please pause the video and read through these. Then think about all the technical steps it will take to build the functionality that will be tested at the end of the 2-week time box. Then come back. Do you see how there are more technical questions hiding under the details? How, for example, are we going to determine the timestamp when the reservation was made so that a premium member can cancel without a fee? Where are we getting the member's status as premium or not premium from? And what about the second to last one? How are we going to notify the hotel? By email, database notification, text message, automated phone call? As you can see, answering all of these questions and doing so quickly requires immediate access to the product owner so that developers lose absolutely no time. Because remember, the time box is set. Developers must demonstrate a shippable product that can be released at the end of that time box in the sprint review meeting. That can quickly get very stressful. As we said before, the product owner stores user stories in the product backlog. The nature of this backlog depends on the product and on the organization. Sometimes you will find just the user stories with their index numbers, as in the example to the right. Sometimes you might already find some very technical requirements. That is especially true if you're working in a hybrid waterfall agile environment in which the scope has already been more clearly defined in a scope statement or use cases during the initiation phase. Look at the rightmost column in the example. This is where you see the priority column. Here the product owner assigns priority numbers to the user stories and their implicitly connected features that she wants the team to build first. As you see here, the database of the user stories is in fact sorted by the product owner's priorities. Then there's another really important column, perhaps the most important column for all the technical people on the team who are going to build the product, the estimation column. As you can see, this column contains numbers. These are called story points. Story points are estimates of effort. They depend on the amount of work required to build the user story, the complexity of the work, meaning how hard it is to build, and the risk and uncertainty, especially if this is something the team has never built before. Story points are a unit of measure for expressing an estimate of the overall effort that will be required to fully implement a product backlog item or any other piece of work. When we estimate with story points, we assign a point value to each item. The raw values we assign are unimportant. What matters are the relative values. A story that is assigned a 2 should be twice as much as a story that is assigned a 1. It should also be 2/3 of a story that is estimated as 3 story points. Instead of assigning 1, 2, and 3, a team could instead assign 100, 200, or 300, or 1 million, 2 million, and 3 million. It doesn't matter. It's the ratios that matter, not the actual numbers. Because story points represent the effort to develop a story, a team's estimate must include everything that can affect the effort. That could include the amount of work to do, the complexity of the work, and any risk or uncertainty in doing the work. Certainly, if there is more to do of something, the estimate of effort should be larger. Consider the case of developing 2 web pages. The first page has only 1 field and a label asking to enter a name. The second page has 100 fields to also simply be filled with a bit of text. The second page is no more complex. There are no interactions among the fields, and each is nothing more than a bit of text. There is no additional risk in the second page. The only difference between these 2 pages is that there is more to do on the second page. The second page should be given more story points. It probably doesn't get 100 times more points, even though there are 100 times as many fields. There are, after all, economies of scale. And maybe making the second page is only 2 or 3 or 10 times as much effort as the first page. But what if the second page contains not just simple text fields, but some date fields with calendar widgets that pop up? Some formatted text fields like phone numbers or social security numbers, and perhaps other fields that do checksum validations as with credit card numbers. This would mean that the page also requires interactions between fields. If the user enters a Visa card, a 3-digit CVV field is shown, but if the user enters an American Express card, a 4-digit CVV field is shown. Even though there are still 100 fields on this screen, these fields are much harder to implement. They're more complex. They'll take more time. So the effort just got much bigger. Lastly, the risk is bigger too. There's more chance the developer makes a mistake and has to back up and correct it. So there will be more story points because of that. Additional risk often also comes from lack of clarity. If a team is asked to estimate a product backlog item and the stakeholder asking for it is unclear about what will be needed, that uncertainty should be reflected in the estimate. or if implementing a feature involves changing a particular piece of old brittle code that has no automated tests in place. All of these risks should also be reflected in the estimate. Now that we know the story points, the backlog and sprint planning meeting is next on the agenda. This is a collaborative effort involving the Scrum Master, who facilitates the meeting and is in charge of all the reporting and makes sure everybody follows the process, the product owner, who clarifies the details of the product backlog items and their acceptance criteria and is in charge of all major decisions, and the Agile team, who define the work and effort necessary to meet their sprint commitment. This meeting lasts roughly 1 hour for every week of a sprint. Sometimes 2 or 3 sprints will be planned ahead, sometimes all and sometimes only one. That depends on the risk of the project and definitely on any schedule and budget constraints. I have often seen budget constraints that determine the number of available sprints, so that story points need to be distributed wisely to minimize the risk of bugs and rework and to maximize the size of the release at the end of each sprint. This is why it is important that the entire team agrees to completing the set of product backlog items that are being assigned to each sprint. Because this agreement defines the sprint backlog and is based on the team's velocity or its work output capacity and the length of the sprint. All of these define the sprint forecast, which is the major measurement based on which the quality of the team's work will be evaluated. Here is an overview of the entire sprint planning process. Please pause the video for a moment to read through all the steps and then come back. Note that the definition of done is incredibly important here. Being done means that the team is aware of what is expected of them to deliver and that they have delivered just that. Done is a means of transparency. It makes sure that the quality of the work fits the purpose of the product and the organization. It's time to talk about one of the most important measurements for work quality in an Agile project. That is velocity. Velocity is the amount of work that a team can complete during a single sprint. Velocity is calculated by taking the sum of all the points for all fully completed user stories in the sprint, not the ones that you have started or that are almost done, just the ones that are completed, tested, and ready for release. The velocity of a sprint, which is essentially the speed and the quality with which the technical staff can get the work done that was planned at the beginning of the sprint, then determines how many story points are being assigned to the next sprint. Velocity is the major metric for sprint forecasting. In the example here, we see a product backlog to the left. From this product backlog, the team pulls the number of story points and obviously the associated user stories into the current sprint that they want to commit to completing. That is the sprint backlog. The number of points is based on the previous sprint's velocity, that is the story points that were successfully completed previously. So in our example, the estimated velocity for the sprint backlog is 26 points. Let's hope that the team was correct in estimating what they could get done and did not overpromise. Now let's look at the end of the sprint. Uh-oh. Out of the promised 26 points, the team got only 18 completely done. 3 are in progress, but they don't count, and the 5 that weren't even started certainly don't count. So the actual team velocity has decreased from 26 points to 18 points, and the user stories that were not completed, those 8 points, are carried over into the next sprint, for which the team can now plan only 18 points. This also means that any 8 points that were already planned for the next sprint will be pushed out, unless the team really ramps up and finishes the 18 points early and can make up for the otherwise delayed scope. As you can see, sprint planning based on velocity means the pressure to perform is on. The good part about user stories and sprint planning is that theoretically, each individual on the technical team always knows how what she is building fits into the overall design of the entire product. That is because the entire technical team has visibility into the product backlog and the sprint backlog at all times. Once a team member commits to completing a specific item, they will be reporting on their progress in the daily scrum. The daily scrum is a 15-minute stand-up meeting in which each team member reports on what they have finished the day before, what they're working on the current day, and if any help is needed, what the help is that they need. This reporting is absolutely critical to making Scrum work. It keeps technical people productive and accountable. Because honestly, who likes to freely admit that they're running into problems they can't solve? So when should you, as the product owner and project manager, use high pressure, high visibility agile methods to get something built? And when should you use lower visibility, lower pressure waterfall methods? As you can see on this chart, that really depends on the technical degree of uncertainty here shown on the horizontal x-axis. If everyone knows their job well, and there are no bad surprises hiding anywhere in the design, a linear waterfall approach might work well, especially if all the technical requirements are well defined and not too complicated to build, like a website, for example. But if you aren't quite sure what is technically needed to transform your user stories into a product, or if this task requires skills that nobody in the organization has, or if people on the team cannot agree on a way to build what you need, that makes the problem complex. And the more complex a technical problem gets, the better a gradual, incremental approach will work. For example, when converting the database backend for a bank's account management system from a relational to a non-relational system. This is where agile models shine because they reduce especially financial risk. And if you are at the completely exploratory end, which happens often in high-stakes, one-off industries such as aerospace, when you build a satellite that does what no one has done before, you're looking at a high-risk requirements and technical innovation, which means you will use the best parts of each model, predictive and adaptive, in a hybrid format, to figure out how best to control scope and implementation chaos while still being accountable for both schedule and budget. That sector of this diagram is not for the faint of heart. So here's your summary of predictive and adaptive models. Please pause this video and look over these points to remind yourself of all the things you have learned up until now. Now that you know almost everything there is to know about the possible models to use when developing, we need to take a step back again and look at, you guessed it, the project lifecycle, or PLC. What we were just talking about is the core piece of IT project management, which is what you're seeing here in the gray box. This is where you are in charge of building the product or service and ensuring that your project is on track to delivering the value it has promised to build, and a great number of other things that are not part of but needed for product utilization. This is also the area in which the project spends the most money. On the two sides of the SDLC are initiation, where your project is defined and assigned to you, and closing, where you basically clean up after yourself and the project team. So when companies state that they do Agile, they are hopefully talking just about the gray box and not using doing Agile as an excuse to get rid of the orange box, the project lifecycle. However, unfortunately, too often companies use the word Agile when really they should be talking about unorganized chaos because they think they can do without the initiation and the closing phases. And that is a big and often very costly mistake. In this module, you'll learn more about how project value is really the highest point of project success. We saw how firms benefit from a clear product development process and a flexible but structured project lifecycle. We spent some more time on predictive and especially agile models and revisited the criteria for when to select which kind of model for your project. Thanks for watching. I look forward to seeing you in the next video.